My bad. All right. So yeah, today we were going to start with subsets. Subsets are, and again, I try to use like a non-mathematical definition just to help you out here, but any combination of the elements of a set. Okay, so any parts of the set that you have, but with a subset, this also includes the empty set and the original set. Okay, the original set is just this one right here. So like I have this A written right there. I don't know why that was circled. So like our original set here is A equals 1, 2, 3. Okay. So that's what I mean by the original set. The empty set, I have that symbol right there in red. We haven't talked about that yet, but that is that circle with the line through it is the empty set. The easiest way that I can explain this, that is, if like, you know how we do the brackets for the set? We have the brackets for the set to signify that we're talking about a set. So if my hat was the brackets and that was the set, and the elements that I had are my AirPods and my keys. Okay, my AirPods and my keys are in the set, right? So I can come up with different subsets of my set. Okay, my set would be, I could do just the keys, right? That's a subset. Or just my AirPods, that's a subset. Or I can do the original, the keys and the AirPods would be a subset of that set. Okay, but also if I take both of them out, the empty set, my hat is empty now, and that this counts as a subset because the set is still here. Even though everything is out of it, the set's still here. Okay? So the empty subset is a subset of the original set there. Okay? So if we have A is equal to 1, 2, 3, the set of 1, 2, 3, that is our original set. You can come up with actually 8 different subsets. You can do the empty subset, okay? 1 would be a subset, 2 would be a subset, 3 would be a subset, and then 1, 2 would, oops, I didn't mean to erase that. And then you could do the subsets with 2 in there. So you could do 1, 2, 1, 3, 2, 3, okay? And then also a subset is the original 1, 1, 2, 3. So you come up with 8 different subsets for that. This is, I think you actually do have a topic on this too, but one of the things that can help you is trying to figure out the number of subsets that you have. The number of subsets that you have is always 2 to the n. 2 to the n, where n is the number of elements. Okay, so like if I was trying to figure out how many subsets I could come up with here, just because I'd make sure I get them all on the test or whatever, there are 3 elements here, 1, 2, and 3. Okay. So if I do 2 to the third power, that's 8. That tells me that I can create 8 different subsets. Okay. This is, I was trying to think of an example here. We had this example last class, but if you have like, I don't know, you go to Five Guys and there's like 12 different toppings that you can get for free, right? To figure out how many different subsets of different combinations of toppings you could create, you would do 2 to the 12th, and that would be how many different cheeseburgers you could create or whatever. Okay. Another symbol right here, the subset symbol, is this sideways U with a line underneath. In my brain, I think about that as like less than or equal to, because this tells me, and I'll show you why in just a second, this tells me that it can equal the original one. Okay. The original one is one of my possibilities. Okay. So down here, you'll see why I say that, but a proper subset is all the subsets that we have up here except the original, okay? Because the original one is kind of the same as the original, like it's the same thing. So it's not really a proper subset is just technically part of the set, the whole set. So they call it a proper subset, and if you notice this symbol is just a sideways U, it doesn't have that line underneath. So to me, like my brain just goes to like less than, it can't equal the original, okay? So proper subsets are all of these subsets except this original one right here. It cannot be 1, 2, 3. So the way you figure out the number of proper subsets is you just figure out the number of subsets and then you subtract 1 because it's all of them besides the original one. Trying to think if there was anything right there. I'll scroll down just a tad right there, but that symbol also is, you also have a line through this one, which means it is not a subset of, okay? So anytime you have a line through it, it is. The only weird line one is the empty set, where, the circle to the line means the empty set that is Still a subset. Oh, one thing to note here is, sorry, I used to make this mistake and I kind of made it my 8 a.m. But the bracket tells us the set, right? So this is the set of 1, the set of 2, the set of 2, the set of 1, 2, right? We don't do a bracket around the empty set because the definition of this symbol is the empty set. So like the bracket tells us that this is a set. Well, this symbol automatically tells us that it is a set. Okay, so you don't have to put a bracket around that. All right, let's go work some problems on that area right there. We did those. This one. All right, so this one is just going through the different symbols and the difference between a set and a proper set. So here, 12 and 15 is a subset of 11, 12, 13, 14, 15. That would be true, right? 12 and 15 is part of that set. 1, 3, 7 is a subset of the empty set. That is false, but it would work if you switched it. The empty set is a subset of 1, 3, 7. That would be true, okay? SVWX is not a subset of SVWX. That is false. It is a subset. It's just not a proper subset, okay? Again, that's what I think about the line underneath. It's kind of like it can equal that. And then CDFG is a proper subset of CG. Again, those are switched. That's going to be false. Let me do another one of those because I don't feel like we got the variation that I wanted. Yeah, let's do. All right, 11, 12, 14 is a subset of 11, 12, 13, 14, 15. That would be true. The empty set is a proper subset. There's not a line under that. That's how I know it's a proper subset. The empty set is a proper subset of 3, 5, 6. That is true, right? If I take away 3, 5, and 6, the set is still there. So the empty set does work. CDFG is a proper subset of DF. That's going to be false. Those are switched. DF should be a proper subset of CDFG. And then PQRTZ is not a subset of PQRTZ. That would be false. It is a subset. It is not a proper subset. Okay. So writing subsets, kind of a pain to do these. So the first thing I would do is, like, I already kind of jumped ahead, but you got 4, 3, and 2, right? So 2 to the third power is 8. I should be able to come up with 8 different sets. So if you do the empty set, and then you can do each one individually. 4, 3. Oh, I forgot to put 2. You do have to put a bracket around each of these, so it is a little bit of a pain. So that's each one individually. Now you do pairs. 4 and 2. 4 and 3. I don't know why I did those out of order. And then what's the other one? 2 and 3. And then the last one would be all 3 of them. 4, 3, 2. Right? Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. I forgot a comma right there. So yeah, make sure you get your commas in between. Alex will probably warn you and not count it wrong automatically, but those are right there. All right. So again, it does helpful to know how many number of subsets you have there, just because then you know how many you have. You got to make sure you read this one because I didn't read it last class and got it wrong. But Latoya is doing research to city newspaper on 3 topics: food, housing, and jobs. Okay, this is a sentence I skipped and just started doing it because I knew it was about subsets. She can choose to write about some or none of them, but not all of them. Okay, so really it wants the proper subsets. So she could write about none of them. She could write about one of them: food, housing, or jobs. She could write about 2 of them: oh, I forgot to. Food and housing, food and jobs. So then I need housing and jobs, right? Or she could, no, she's not going to write about all 3 of them, right? So there should be 2 to the third power is 8, but then you take away the all because it's just proper. So there should be 7. 1, 2, 3, 4, 5, 6, 7. So that should be correct, okay? I'm going to check it, make sure, because I missed it last class. But yeah, make sure, because a lot of these say that she can write about some of them or not all of them, or they're going to sample the food at some of them, but not all of them. So when it says not all, that makes it a proper subset. It takes away that total one. Determining the number of sets on this one. So you just use the calculator. There is 1, 2, 3, 4, 5, 6, 7 elements in this one. So you do 2 hit this little XY to get the exponent. This button, well, y'all know where the exponent was, right? 2 spots above the 8 there. 2 to the 7th would be 128. So that would be my number of subsets. And then the proper subsets, you just take away the original one, so it's always one less. Okay. The next one. 1, 2, 3, 4, 5, 6. Okay. Henry's going on trip. He can take some or none of the 9 novels from the list below him, but he can't take all of them. So he could take those. There are how many? 1, 2, 3, 4, 5, 6, 7, 8. Did I count? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 2 to the 9th. How many different ways can he choose the novels to take? It would be 512. Wait, he can't take all of them, though, so 511. So you subtract. Is that really a fire alarm?
Because it's in building 44, it's in the parking lot. A vehicle caught on fire.
There is a vehicle fire in building 44. 5 cars were stay out of the area. Do not return until an all clear message is issued.
A vehicle caught on fire?
In building 44.
They just sent it out like a minute ago.
That's unfortunate. I bet how many kids do you think are in building 44? They're freaking out right now.
In like the city
They said,
roads, it like,
yeah, they said it's in the parking garage, but I can't tell.
Like the parking garage over here?
I think so.
I was trying to think of where building 44 was.
It's the Lazara, just the big fine arts center.
You think by the green?
Yeah.
Oh my goodness. Okay.
Someone left something on. They weren't supposed to.
Yeah. So strange.
Oh, for fires? Who knew?
Okay. I think that's might be the first time I've ever had that happen to me here. All right. We'll jump back into it since the fire's on the other side of campus. All right. This next part, the universal set. So they use a U to talk about the universal set. That is just like the letter U. The universal set is kind of like every possible option because most of the time, just like that, the traveling book one, he has all these books. So like that's all the possible options that he has, and then he could do different sets of that. So they got to signify like what we're looking at here. I said the 5 Guys example earlier, like all their toppings that's the universal set. Okay. So they use the letter U for that. So in my example right here, U is equal to A, B, C, D, E, F. And then I made the set A, which is B, C, E. Okay. When you see this apostrophe, A apostrophe right here in the red, y'all kind of know what this means, but just maybe not the symbol or this word. It's called the complement of A. The complement of A means what are the elements that are not in A. What are the elements that are not in A? Okay, so when you see the apostrophe, you look at what's not in A. So you got to have the total amount, the universal set here to figure out what's not in A. So if A is B, C, E, then not in A is A, B, D, and F. Okay, did I forget B in there? My last class didn't tell me that either. 8 a.m., your brain's not thinking right, so I didn't put a B in here. Oh, wait, B is in A. See, y'all aren't telling me. B, C, and E. All right. Sorry, let's double check. B, C, and E are in A, so A, D, F is not in A, right? Okay. Sorry, y'all weren't stopping me there. So one thing to note that is if you take what's in A and what's not in A, that gives me everything, right? You're either in A or you're not in A, so that has to add up to be all the stuff. So that does make sure that you get everything in there. But again, just when you see this apostrophe, that's kind of where our brain needs to go. They call it not A for short, but it's what's not in A, okay? So a lot of times when we get a little further, if they only give you A, but you need to find not A for a reason, like write it down so you have both of them right there to look at, and that does help you a bunch. Let me jump back over here and see. All right, so this one is finding the sets of these. The universal is FGHPQ. This one says, suppose we know that A naught is GP. So again, you're either not in A or you're in A. So if GP are not in A, that means A has to be F. G's already in there. H, P's already in there. Q, right? So A naught is GP. A has to be FHQ, okay? If B is GHPQ, then B naught would be F. F's the only thing that's not in there, okay? So the whole universal should be covered by A and A naught or B and B naught, whatever. So when you see that apostrophe, that is what that means. It's the naught, okay? It's called the complement, but it means the naught. What's not in there? They got a real world one here. Yeah, this one, I did this one last class. I don't want to do the planets, although this one's not any better. I'll do the blood type. That's fine. Okay, this one may not hurt to write down, but it is. We can probably do it without writing down, I think. You got all the different blood types, who they can donate to, who they can receive from. So let X naught be the set of blood types that AB negative cannot donate blood to. Okay, AB negative cannot donate blood to. So the opposite of cannot would be, if X naught is what they cannot donate to, then X would be what they can donate to, okay? So all we need to do is look at this chart at AB negative, and figure out what X can donate to. So it'd be AB positive and AB negative, right? Right here, AB positive, AB negative. All right, so X naught is AB negative cannot donate to. So X would be what AB negative can donate to. That would be AB plus, and keeps jumping on me, AB negative. Everybody good with that? I feel like that looks right. All right, let Y be the set of blood types that AB positive can donate blood to. Okay, so that would just be AB positive can only donate to AB positive, right? Let Y be the set of blood types that AB positive can donate blood to. So Y naught would be the ones that AB positive cannot donate blood to. Well, if it can only donate to AB positive, then all the other ones would be the ones it cannot donate to, which is not fun. I got to do each of these, right? It said it can donate to AB positive, right? So we skip that one. This is nice that it gives me the chart right there, right? Let's double check this. Let Y be the set of blood types that the type AB positive can donate blood to. So Y naught would be the ones that it cannot donate blood to. Let's check it, see if we did it right. Yes, we did. Okay. All right, the last bit of information. This is kind of the last rule that we learned because, like I said, on next week, the Venn diagrams are just visualizations of what we're doing right here. There I got the text message. I was kind of wondering how I never got the text. Oh, I'm on Do Not Disturb. That's why. The union is a U symbol. Don't get this confused with universal. The universal is just like the letter U. The union symbol's a little wider. The union and intersection. Union, they use the word or, okay? Union is the word or, and way I think about this is like union marriage, it brings together, okay? It brings together. And a lot of times in math, when you see the word or, it's an addition. You think addition. So this is an addition. You're taking set A plus set B, and you're combining them, okay? That's the other word I like to put in there is combine. It brings together, it combines them, okay? I'm going to write that combine there, all right? Didn't write combine. Okay? It brings together, combines like the sets, okay? So when you see or, it's what's elements in A or B, so you could be in either one and it combines them. The intersection uses the word and. That's the word you associate with the intersection. We'll talk more about the intersection. It makes more sense when you have the Venn diagrams, but I'm saving that for next week. It's what they share, okay? And is what they share. Which elements are in A and B, okay? These aren't hard when they're just by themselves and you're doing stuff, but when you start mixing in the complement and different things like that, it does get a little tricky. Some of the pictures and different things, it's just like multiple steps, and you just got to take it step by step, okay? All right, let you finish writing for a second. All right. So on this one, it says B intersect C naught, okay? So on these problems that are longer like this or have multiple steps, you got the complement and the and. Take it step by step. I'm going to go figure out what C naught is before I even start worrying about that and, okay? So my C naught, C is QRS, so C naught would be FKMY. FKMY. All right. So now I can look at the and. I want what is in B and C naught. So what do they share? So we're thinking share on this one. What share an F and an M? Okay. It makes it so much easier if you write down C naught instead of trying to think in your head, okay, what's not in C and in B at the same time? Write down C naught, and then you can just easily look at it. On the next one, I always think about like order of operations. So like this kind of looks like an exponent. So I start with the exponent, and then I do the and or the or. So on this one, you do parentheses before you do exponent, right? So I'm going to do in the parentheses. So if I want to write down B union C, this is or. So whatever way you want to think about that, I'll write bring together. B union C. Let me write that first. So B union C. These do not have to be in order in Alex. Like you don't have to do alphabetical order. Oh, FMQ. Bring together with C. I already have a Q in there, so I don't need to write that again. So it'd be FMQRS. I can find any of those letters, any of these letters right here in B or C. So I bring them together. So if you notice, a lot of times the union has a lot more elements in it than the intersection because the union's bringing a bunch together, and the intersection is just what they share. All right, so that's my B or C. Now I do the not of B or C, right? So this would be what's not in here. What's not in there? A K and a Y. F, K, M, Q, R, S, Y. Okay. So this is why it makes it so much easier if you write the first step down and then find it. Okay, this is something that's going to be tricky next week. That's why I'm emphasizing it now. All right, do another one of those just because these can get tricky. B union D naught. So B or D naught. B or D naught. So the first thing I would do is write down D naught. The complement of D, D is 2, 4, 6, so D naught would be 5 and 7, all right? So now if I want or, I'm looking at what brings together. What brings together B and D naught? So B and D naught, I'm bringing those two together. It would be 4, 5, 6, 7. Again, in Alex, you do not have to write them in order, but that was pretty easy to write in order. You don't have to write 7 twice because 4, 5, 6, 7 is in B or D naught. So again, write that down. So on this one, on part B, you have B naught and, so it's what they share, B naught and D naught. Well, we already have D naught written. Let's write B naught. B has 4, 6, 7, so B naught would have 2 and 5. 2, 4, 5, 6, 7. So now I combine this one. I'm sorry, I don't combine. I share. What does 2, 5, and 5, 7 share? It would only share a 5. Okay? It makes it so much easier if you write down piece by piece. Write down the B naught. Write down the D naught. Then you can just look at it and see if they share instead of trying to think about all that in your head. So really try to write these step by step. All right. The last topic here we have today has to do with unions and intersections of the empty set or the universal set. There's kind of a pattern you'll see, and we can talk about it for just a second. But you don't have to know the pattern. You can just look at it and think about it. So C union the universal set. Okay, so you see the difference between the U's. When I go to write it, I can't write the difference. It's mine. U's look like U's. So C or U. If I bring these together, right, what is in C or the universal set, it ends up just being the universal set, right? Because what do these, if I bring these together, not what they share, if I bring them together, what is in this or this? Well, it's all of these, right? Because I know all of these are in there. Does that kind of make sense? Okay, so C union the universal, what's in the C or the universal? It's all the universal stuff. The other one, C and C naught, again, if you want to write down C naught real quick. HPR, so that would be QXY. Okay. What is in the intersection of what's in C and what's not in C? What is in the intersection of what's in C and not in C? Well, you're either in C or you're not in C. They don't share anything. So it is the empty set. Okay. All right, so a couple like rules to help you get through those. Again, they're not hard. You can kind of think about it because you can just look at this and tell there's nothing that they share. So it's empty, okay? But just kind of just the thought process of this, and I use the word or instead of my union symbol just because it's hard to read. A union the universal. If I say what's in A or the universal, then it's just going to be the universal because it's all, the universal is going to be all of it, okay? If I say what is A intersect the universal, what does A share with the universal? It's actually going to just be A because they would share, the universal already has everything in it. So A is going to share everything that's in A. This is just kind of some of the weird things that happen here on these. And then on the right side, A union the empty set. Okay, if I bring together A with nothing, then it's just going to be A. That kind of makes sense, right? And then if I, what does A intersect with the empty set? What does A share with the empty set? Well, there is nothing in the empty set, so it can't share anything. Okay. And I guess the one that I didn't write right here was the one that we just did on that problem, so we've kind of seen it. But A, we can do both of them. A union A naught. If I say what is in A or A naught, that would actually be everything, right? Because you're either in A or you're not in A. So if I combine those, it would be everything. I'm going to write this right here so you know. Universal, and this is my union. And then if I do A intersect A naught, what does A share with A naught? We just did that one. It is empty set because you're either in A or not in A, so they don't share anything. Okay, so these answers always kind of work out like that. It doesn't matter what actually is in the set; it will be one of those answers. But again, you don't really have to like memorize these or write these down or anything like that. When I said the rules, like you can just think through these, and it shouldn't be too bad. All right, I believe that got us through. That is the last topic on there.